Alright, hello world, welcome back to another video. In this video will be another Leetcode video. I come up with a project idea that we can work on. So, we're going to follow the algorithm study plan that we've created. We created, Leetcode created. So today we're going to hopefully do two Leetcode challenge. 977 squares of a sorted array and 189 rotate array. Alright, so we'll go ahead and get started. Given an integer array num sorted in non-decreasing order, which is increasing order, return an array of the squares of each number sorted in non-decreasing order. For example, if the array is 4, negative 1, 0, 3, 10, 0, 1, 9, 1600. Yeah, that's that. Alright. So, let's see. Alright, so let's go ahead and get started. I think it's not going to be that hard if I want to try a cheating message first. See if this would even work. Oh, can raise to the power of. Interesting. Alright, well then we want to say num squared equals, we're going to use a list comprehension here. Raised to the power of 2. Right? For nums. Alright, perfect. So that does the job of squaring it. Now we just need to sort it. So there is a few sorting algorithm we can use. I think there's one just dot sort, I think. Can they disable certain functions? Because they might disable it. Oh, never mind. Well, let's submit it. Yeah, that's one way to do it. I guess that's one way to do it. Or if we really want to save some space, I guess we don't even need to create a variable here. Let's use the same memory. Yeah. Well, it doesn't really help. But, yeah. That's one way to do it. That's a cheating way, though, because we're using its default sorted. Now, we definitely can implement a different algorithm, like merge sort. That's literally the one. That's literally the only one that's getting out on top of my head right now. But yeah, that's one way to do it. If we have time in this video, we're gonna come back and see if we can implement using different sorting algorithms. But for now, let's go rotate array because it's a medium. When you say medium, it's gonna, what does that mean? It's gonna pretty much take the rest of the video. So let's go and take a look. Good, so that doesn't really show us, you have to do it in this space-time complexity, because that means I have to implement it using a specific algorithm in a specific way. And, oh look, it wants us to do, we don't want to return anything, just modify nums in place. If you don't know what does in place mean, in place just means modify the array itself. Don't return new array, just modify this array, this nums thing. Alright, so let's see the instruction here. Given an array, rotate the array to the right by k steps, where k is not negative. Right? So for example, that's how you do it. Alright, that's how you do it. So let me copy and paste it to the whiteboard. right? So that just means shift everything to right by 3, right? Shift everything to right by 3. So here's my algorithm right now, how to work is 1 goes to 4, and then 4 goes to 1. So really just swap. 2 goes to 5, 5 goes to 2. 3 goes to 6, 6 goes to 3. 4 goes to 7, 7 goes to 4. Yeah, and by implement that, that sorted everything. Let's see what it work on a even number, even list. Yeah, text. All right. So that's another example we can do is shift 1. If we're shifting 2, then we'll move to 3 like that. Like that. Perfect. So this would total take us, let's see. So 1, 2. So technically, for 1, 2, 3, 4, 5, 6, 7, 8. I'm thinking I should write a loop then. So I think we're really just doing half of them, right? This just loops, we just need to do it 2 times here, right? Assume each time when we do, what we does is, we just swap them. Swap both numbers. Yeah. This, I suppose the same thing will happen. 1, 2, 3, 4. For I in range. Alright, the first thing first, we're gonna test out what will this do. This round up or round down? This would round down. Let's go ahead and do a seal function here. Seal just means a round up. I always round up. Oh, we don't. See if it's this way. Okay, 4. Sure, so that will work. So let's just say number of times, right? Mass the CO lengths of the nums. Like that, perfect. And then so for I in nums, a range of the lengths of nums. Right? So here's basically what's gonna happen. We do this. We're gonna modify in place. Ooh, that might mess it up. Because if we are changing it in for loop, theoretically not really. Okay, 1 swap it was 4, 2 swap was 5, 3 swap is 6. Oh no, never mind, I messed up the rule here. Here how it's supposed to go. 1 goes to 4. This part is no problem. However, when you backtrack, 7's supposed to go to 3, right? Yeah, 7 need to go to 3. 6 need to go to 2. 5 need to go to 1. So that's not going to be an easy task then to rotate it. So I guess here's what our logic can be. Right, here's what our logic can be. Let's try to loop through half of it. Let's see what's gonna happen if we loop through half of it. Like right there. That's we're just gonna get 1, 2, 3, 4, and see if there's any way we can manage it. 1 need to go to 4, right? But 4 need to go to 7. 7 need to go to 2. 2 need to go to 5. 5 need to go to 1. Wait, this is. I'll go to 4. 4 goes to 7. 7 goes to 3. Right? 7 goes to 3. 3 goes to 6. 6 goes to 2. 2 goes to 5. And 5 go to 1. So I guess it works maybe. Okay, let's try to implement this. Let's just say current index is I, right? Next index is whatever I plus 3 is. Or not I plus 3, I plus k. Right? So another word we can say nums bracket cur index. No, num bracket, and then we also need to store value. Swapped index value. That need to equals to. I'm saying to num right now. Let's see, nums. I guess we don't need them after all. Nums bracket swap index value. No, num bracket current index equals to. No, current index plus k. So swap index equals index current index plus k. Now if swap index is greater than length of nums minus 1, which it shouldn't, right? Keep in mind is index. So it should never be greater than the last index. If it is, let's see. So let's say 7, right? 7 is index 6. 6 plus 3 is 9. But I actually want to get it equals 8. Then I need to go to 7 to go to 3, which is 2. So you need to minus the length of the list. Alright, let's do swapping next. Alright. Well, I guess that could be our index. Right? Maybe? Okay. Because it's not just they swap, because 1 to go to 5, but 5 don't go to 1. No, 1 go to 4, but 4 don't go to 1. So that's a problem. We can't really swap it. Therefore, that's why we need to keep track of the values. So swap, and it needs to be in place, which make it harder for us to do. All right, swap index. Swap index. What should this be? Now swap value. So value one. Swap this is nums bracket. Swap index. Right? I'm thinking if a for loop makes sense here. Yeah, I guess it's just learning some norms. Alright, but the problem is I can't sort really by index. Can I? Yeah, the problem is I can't really sort by index. Because that doesn't make sense. Well, the issue here is this will work for the first time. But then the second time, what I want to look for is I want to look specifically for the swap index. I'll also do swap index. Let's see how bad our nums can be. Okay. Alright, we're gonna do this one. Let's sort once, see what's gonna happen. Because this shows everything too. Well, I think we're really just overcomplicating it. Why can't we do another logic? Let's do this logic, their explanation logic, rather than this weird swapping logic. For I in range of k, yeah, because this didn't really swap correctly anyway. So, all right, now we're gonna push everything to the right by 1. Well, that's gonna be a lot of swapping though. Swapping. It's gonna be a lot of swapping numbers. All right. Well, let's do it this way. So we're just gonna swap. Right? We're gonna say current value. Okay. So current value, that would be, that's how much we need to shift by. Right? So we need to say shift by that every time. Alright, well, let's see. So then when we do for I in range, or for j in range of the length of nums, right? That's immediately, well, whatever. Alright, so let's say nums bracket j We don't really need this. We're just in shift by with the next number, right? Nums j. So let's say temp equals nums j plus 1. Nums, there will be an issue. We're going to deal with that later. Nums j plus 1 equals to nums j. And nums j okay. Well, there's still nowhere for us to store the nums though. Is there? Well, yeah, because that's the issue. See how we store the next number in, right? So in this case, we want to swap it to here. Or I want to swap it to here. However, what's going to happen is this 2 need to be immediately swapped with the next number. Alright, let's do this. Let's say because we want the temp to be able to keep track of everything. Alright, let's say if temp is -1, that means we're at the start, then this is what we want to do. However, if the temp is not -1, let's say it's next number 2, then nums j plus 1 should be equals to temp. Temp2 temp, and then we can say temp equals temp2. Let's see what this gives us. Hopefully not a even a loop. Alright. Okay, out of range. This is expected because at the end you can't do +1 anymore. Alright, so here I have to do another if statement. So if j equals length of nums minus 1, then what we need to do, okay, what we need to do now, right, if it's length of nums minus 1, yeah, okay, my logic is a mess right now. Alright, well, if it's equals to that, yeah, and then we'll just have to copy. Yeah, it's gonna be. How about this? Actually, all I'm gonna do is I'm just gonna say try except. I'm gonna remove them later. Just want to see what's the Okay, totally messed up, but you know, I'm just gonna say break. So it's gonna happen now. So you see it after the first step. Okay, not bad. Not bad. Now, all we need to do is change this 1 to 7, which is what we didn't handle yet. Right? That's all we need to do. Change this 1 to 7. However, how suppose we do that? Ooh, wait a minute. If there is an index error, what would that do? Oh, shoot, I need to do a break here. Ah, good. That gave us the right answer for first iteration. Let's run it. Good, it gave us the right answer. Let's just run it. Alright. See what happened. Hey. You said... Oh. Oh, man. Okay. The existence of temp here basically says that it has to be a number that cannot exist in a real list, because that's just, the temporary number. Or, I don't know. You know what? Actually, let's do this. Let's start with some. It don't have to be an integer. It don't have to be an integer. Alright, gonna do a few precondition here. So, if length of noms equals 0 or length of noms equals 1, just return noms. Right? Well, I can agree that's what we're supposed to do. Alright, we're gonna have a time limit here. That will probably be an issue. Yeah. Yeah, this time limit. This is not friendly. Oh my god. Okay, well, that's a gigantic number. Let's take a look at your hints. How about that? Take a look. That's our idea, right? But it didn't work. Well, I saw it. So we want to reverse an array. Frankly, I guess all I'm doing is I'm really just taking these part number and put it at the start. Right? What if we don't really need these complex logic? What if we just do this? See how the k and the last number are the same, so we can just say last part is nums bracket 0 : It's gonna be so we want to start at length of nums minus this is index number 4 minus k all the way to the end. That will give us the last part. I'm thinking if we can replace it, right? Hopefully we can. Start part, that will just be this. Nums equals start last part plus start part. Let's see what's going to happen. Alright. Print out last part and print out start part. Yeah, what's wrong with it? Can I not add them? Okay, wait. What will be the result of this list? Yeah, 5, 6, 7, 1, 2, 3, 4, just store in the nums again. Alright, we're gonna search remove a series of elements from this. Remove a range of elements. Let's see if there's a good way to do it. I'll probably have to end soon. Okay. Let's do this. Let's say new equals that nums equals new. Okay, this is really picky. This thing's really picky. Can we not do that? Can we not do what I'm doing right here? Probably can't. But that's why it's showing error here. Let's do that. Cycling, whatever. Alright. Okay. Well, I guess we have to figure this out in the next Leetcode video. Probably. I think we're getting closer to the answer. But I think the problem is like it kind of knows what we are doing here. So it kind of banned us of, reset the value completely, probably. I guess that's what's happening here. Yeah. So we're gonna figure out how can we move the last part to the start. Right, how to shift it. So yeah, I guess that's all we'll do in this video. If you have any question or comment, feel free to comment down below. As always, stay safe and have a great rest of your day. That's me, out.